Okay, guys. Thank you for coming. I'll start the webinar in just 1 minute. Let me share my screen. Wait, before I do that, can you guys hear me? Oh, cool, cool. Okay, so welcome to our last Intro to Science webinar, day 4, and today I'll be teaching you guys physics. Physics is a very complicated subject, so I don't expect you guys to have a complete and 100% understanding, but rather I'm just trying to introduce you guys to physics. So without further ado, let's get to it. So let's start out by asking ourselves, what is physics? So physics is basically kind of like you can think of it as a big puzzle that helps us understand how things in the world around us work and move. So a lot of the time, scientists who study physics called physicists, they usually ask questions like, why do things fall down instead of floating up? How do objects stop and move? What makes things go fast and slow? So these physicists are basically detectives that try to solve the mysteries of how the world and the universe works, and they kind of just use their curiosity and imagination. So it helps us discover the rules that control how everything in the universe behaves. So from small, tiny particles to huge planets to giant stars, you can use physics to understand how they work. By studying physics, we can learn about stuff like forces, and forces typically push and pull things. We can learn how light and sound travel, and how electricity and magnets work. And in addition to that, we can also learn about energy, which basically powers um, the universe itself. And I'll get to that in just a second. So yeah, physics is just an exciting adventure where we get to explore and understand the secrets of the world around us. And right here is kind of a contraption that physicists use a lot called the pendulum. So the first concept I want you guys to know today are forces in motion. So as I said before, forces are basically like pushes and pulls, and they make objects move or change direction. So whenever you push a toy car or pull the door open, you're applying force. And so there are different types of forces. The most, I think one force that everybody knows is gravity. And gravity is a big force that pulls down objects towards the ground on a planet or a celestial body. And that's why things fall down instead of floating up, and that's because of gravity. So gravity kind of changes depending on the planet, depending on the mass and the size of a planet. So our gravity is going to be different from the moon's gravity or Jupiter's gravity. So friction is another force that you probably have experienced before. And that's basically when two things rub against each other and they kind of create a resistance, and this resistance kind of slows things down. So whenever you kind of rub wood against wood, right, you'll feel kind of like a resistance, right? Um, Inertia is another type of force, and that kind of keeps things in motion or keeps things at rest until something acts on it. So a ball, it won't stop rolling. Like if you start rolling a ball, right, it won't stop rolling until a force makes it stop, right? So if you like stop it with your hand or wall, it'll just stop. Um, Motion, so motion is the second concept on the slide. Motion is kind of what happens when an object moves around, right? It changes its position. So it goes from point A to point B, right? So that's motion. It can be in a bunch of different types of directions. So it can be straight, in a curve, it could be just spinning around. Um, so yeah, in order to have motion, you can have forces that apply to an object to speed it up, slow it down, stop or change direction, right? So whenever you kick a soccer ball, it starts rolling, or when you steer a bicycle and it turns, right, you're applying force. And so forces in motion kind of help us um, understand how things like cars, balls, and planets move in our solar system. Before I go on, any questions so far? Celestial, okay, so celestial is just like stuff in space. Okay, so like a planet is celestial, right? Because it's in space. So that's honestly all you really have to like remember so far, just anything in space. Okay, if there are no more questions, I'll move on to the next slide. So energy and work, okay. Yeah, you're welcome. So energy and work. So energy is basically what makes things happen. And as I said on the second slide, energy is like fuel that makes everything in the world work, right? So there are a lot of different types of energy. But for now, I want you guys to I'll teach you guys two types of energy, kinetic and potential. Let me give you an example. Um, of energy, I mean. So whenever you ride a bike, your body will use energy to make the bike move, right? And when the bike moves, that's kinetic energy. So exactly what is kinetic energy? That is the energy of movement, right? So whenever anything moves, that's basically kinetic energy, right? When you kick a soccer ball or run, you're using kinetic energy, right? When you're lifting something like maybe a box, right? You're going to be using kinetic energy. Potential energy, on the other hand, is stored energy that's basically being that's waiting to be used. So whenever you have maybe a basketball high above the ground, or maybe you have say a rock right above a cliff, or maybe like ball above a ramp, right? And if it's not moving, it has a lot of potential energy, right? Energy can change from one form to another. And right here, let's skip down here, important. So this is kind of the universal law of energy. Energy can't be created or destroyed, and it can only be converted from one form to another. And this is one of the most important concepts you need to know of physics. So if you maybe if you're writing stuff down, make sure you write this down. That energy can't be created or destroyed, but it can only be converted from one form to another. And I'll show you an example of how it can be converted from uh, potential energy to kinetic energy. And so that's basically when you jump on a trampoline, right? As you bounce up and down, your potential energy will turn to kinetic energy, and you'll keep cycling over and over again, right? So another example of potential energy being converted to kinetic energy is, let's say, imagine you have like a giant ramp, right? Like one of the skateboard ramps or something, and you put a ball on top, right? So that ball has potential energy, but if it starts moving down, right, it goes down the ramp, it'll have more kinetic energy. So now that's energy. Let's talk about work. And work is just when you use energy to make something happen. So whenever you push a heavy box or climb up the stairs, right, you're kind of just applying work, right? Work's happening. Um, so simple machines like levers or ramps help us do work more easily. So they help us they make it easier so we can lift things, move objects, or just change directions, right? I'll get to simple machines in a little bit, but yeah, that's pretty much it. Understanding energy and work, it basically helps us understand how things move, change, and interact in our world. So yeah, let's talk about simple machines real quick. Simple machines are just like tools that help us do work more easily, right? So a lot of I'll talk about four simple machines here, but there's a bunch of different other types of machines. First of all, there are levers, right? And levers are kind of, so think of a seesaw or crowbar, right? So here's a lever right here. So they help us lift heavy objects by using a long stick and a pivot point called a fulcrum. So this right here, this is a pivot fulcrum, right? So as you push down, this will go up, right? And so this is the pivot point. Next we have pulleys, and pulleys are like wheels, and they have grooves and ropes, right? Over here you see this pulley, and so they help us lift things by pulling down. So whenever you pull down here, an object will go up on another end, right? So maybe you, for another example of a pulley, if you have like a really heavy box here and a lighter box there, right? So that heavy box will go down here, and the lighter box will go up, right? So that's just a basic pulley. Next we have inclined planes. So planes, honestly, a lot of different things can be inclined planes, but they're basically just ramps and slides. And so they make it easier for us to move things up or down, right? They spread the work that we need to apply on objects over a longer distance. So instead of like picking the object up, right, and then moving it down or maybe moving it up, you can just kind of roll the object up on a plane. Now we also have the famous wheels and axle. So wheels and axles are always, they're part of cars, they're part of bikes, they're part of different vehicles that basically help us move objects, right? We don't have to try as hard to move these objects because they reduce the friction and they enable smooth rotation. So, you know, they rotate easily, and by reducing friction, right? Whenever you kind of just rub like two rectangles together, right? Two rectangular objects will create friction. They're really hard to like kind of move compared to wheels. So that's kind of the purpose of the wheels and axles. So yeah, each of these machines has its own special way of helping us do work. All right. Sometimes we can combine different machines to make things easier. There's a bunch of different simple machines out there. So a doorknob, the doorknob on your door is like a wheel and axle. A pair of scissors uses levers to help cut things, you know. And then the light switch can be just like a lever, kind of. So yeah, understanding simple machines, they can help you solve problems, any real world problems, and they can be like secret tools, and that will make your work feel easier. So before I go on to the next slide, any questions so far? Okay, no questions. All right, let's move on. Okay, so now I'm going to talk about light and sound. So you guys are probably already familiar with light and sound, right? So light and sound, they're very important things that help us see and recognize stuff in the world around us, right? So light is what allows us to see. Light comes from a bunch of different sources like the sun, light bulbs, flashlights, right? Um, excuse me. So light travels in straight lines, and you can see this whenever you kind of shine a flashlight, right? Flashlight will kind of go straight. Um, Light also can bounce off objects, and by doing so, it will enter our eyes, and our eyes will interpret the light so we can see stuff, right? And light can also bend or refract, and refracting basically means changing direction. And so this happens whenever light passes through things like water, maybe a prism, and these create really cool rainbows that you typically see, especially after like giant, like very long rainstorms, right? You can always see rainbows, and those rainbows are produced um, because of the light bending off of water. Sound is what we hear, right? You guys can hear me, right? I'm producing sound. Comes from a bunch of different sources, like people talking, music. Music is a very popular sound. Birds, animals, you know, maybe rippling the leaves outside. Sound travels in waves. So whenever you see, if you've ever thrown maybe a pebble or maybe an object into like a body of water, like a pond, you can see the ripples just spread apart, right? And a lot of the time, I just do it. I just throw stuff into the pond because it looks really nice. But yeah, that's basically waves. That's how waves vibrate in the air. Our ears are used to pick up them as sound, the waves that are produced, right? So our ears interpret sounds through the waves, if that makes sense. Um, so yeah, sound, it needs something to travel through. A medium is just like air, water, or solids, right? So it needs something to travel through. So you can't hear sounds in space because there's no air, or water or anything really. Different sounds, they have different pitches and volumes, right? So high pitched sounds are like whistles, low pitched sounds are like drum beats, right? And your ears are designed to recognize each of these different sounds. And understanding light and sound helps us appreciate all the beautiful colors we see and the amazing sounds we hear every day. So that's light and sound. Any questions, guys? You guys can use a chat in case you don't already know, but you know. Okay, no questions. Let's move on. Okay, so now I want to talk about a more kind of complicated topic, and that is electricity and magnetism. And so basically, you can just think of them as two superpowers that work together to create amazing things, right? So electricity, that's a different type of energy, right? We talked about energy in the previous slides. Electricity is a type of energy, and that is used to power our devices. So the computer or tablet or phone that you're using right now is powered by electricity, and the lights in your room are also powered by electricity. And so tiny particles called electrons kind of flow through like wires, just like how water flows through pipes, and that is in the form of electricity. So you can think of electricity as a big loop, right? So whenever you turn on the light switch, it completes a loop and the electricity kind of flows, turns on the light, right? So that's a little bit complicated. You don't have to worry too much about that. But our second concept is magnetism. And magnetism is a force that can attract or repel certain objects. So if you've ever seen like maybe refrigerator magnets or maybe other different magnets, right? The magnets can stick onto the fridges, right? So that's magnetism. These magnets have a special power called magnetic field, and that is basically just an invisible force field around them that can pull or push things that are made of certain materials, right? So magnets are basically made of certain materials. A fridge has a certain material, right? So both of these two are connected, right? So electricity flows through wires, right? And whenever it does, it creates a magnetic field. And so whenever a magnet moves near a wire, it can create electricity. So they're kind of interconnected in that way. Understanding electricity and magnetism helps us design and use things, common things such as motors, generators, and headphones. So yeah, these three objects, you use these three concepts. So their electricity and magnetism are just a dynamic duo that kind of brings power in a type of magic, right, to our world. So any questions so far? Okay, no questions. So either I'm doing really good or really bad, but I think I'm doing pretty good. So let's move on to some real world examples of physics. Okay. So first of all, we have transportation, right? So cars, airplanes, and trains, right? They use physics. So physics allows them to move more efficiently and go fast, right? Keeping us safe. So whenever people modify cars, cars use a thing called aerodynamics, and that's kind of how they move in the air, right? So that's kind of using physics. Um, Sports. So physics plays a big role in sports. So understanding things like gravity, motion, forces. So athletes can kind of before throwing can understand how far to throw, how far to jump, how to score a goal, right? So using physics, they can kind of perform better in sports. Um, Now we have technology. So yeah, technology uses physics every day. Um, Basically, whenever we're creating and using technology, right, we're using physics, electricity and whatnot, and magnetism as well. We also have architecture and construction. So whenever buildings and bridges are designed, scientists or physicists use physics to help ensure that they're strong and stable. They can survive stuff like wind and earthquakes, right? So the way they're built. Space exploration. So physics allows us to explore and understand how big space really is. So it helps us build rockets and satellites and telescopes, and this kind of they build in a way that can help us learn more about the universe, right? So the way rockets are designed, and then we have renewable energy. So physics helps us harness the power of the sun, wind, and water, right? And this can generate clean and sustainable energy, right? Solar panels do this as well. They harness the power of the sun. Wind turbines harness the power of the wind. So yeah, these are just examples of how physics plays an important part of our lives. And so with that being said, I usually conclude my days with fun facts, right? So maybe you might like these. But the speed of light, as we discussed earlier, it's really fast. So science uses meters and kilometers, right? They use these measurements. So that's whenever you're doing physics, you have to use these units, and they're called the standard. I think this SI, right? Standard. I forgot the second part. SI is the standard international system, right? International system of units. That's what it's called. So 300,000 kilometers per second. So you really can't exactly like comprehend how fast that is, because that means it can go around Earth 7.5 times in just a second. So that's crazy. Yeah, sound, as I said before, it travels through the air as vibrations. Sound can also travel through materials like water and solid objects. And you can hear someone talking underwater if you're close enough. So the Earth, we were talking about magnetism before, right? How objects have a magnetic field, and Earth has a very powerful magnetic field, right? And that acts like a giant shield, which protects us from the harmful particles that come from the sun, right? So it's kind of like a superhero force field. And physics, it can be used for fun stuff as well. So roller coasters, parks, amusement park rides, and stuff in movies, they use physics. Scientists use physics to create those. And a single bolt of lightning contains enough energy to power a 100-watt light bulb for 3 months. So that's a lot of electricity in just one moment. So that's really crazy. Okay, so that is it. That was a lot of information. Maybe you guys are having a hard time processing it. If not, I don't think you guys are. Just stay around and ask some questions. But yeah, that was our last Intro to Science webinar. Next week, we will be having an intro to Lua, and it's a programming language. Lua is a programming language webinar for those of you interested in learning how to code. So that's basically, my brother's going to be teaching that, and he's going to teach you guys how to make a game. Okay, so apart from that, if you guys have any questions, to stick around. But have a great day and a great weekend, everybody. Thank you for coming.